Hey everyone, and welcome to This Explainer. Today we're jumping right into the fascinating world of Grade 8 mathematics following your NCERT textbook. We're going to solve some pretty grand mathematical mysteries together, and you know what? We'll do it using just plain, simple, logical steps. So get comfortable and let's get right into it. Here's our quick roadmap for today. First, the Royal Locker puzzle. Then, discovering perfect squares. After that, proving with algebra. Next, exploring math patterns. And finally, you can do this. Section 1, the Royal Locker puzzle. Okay, let's dive right into this. So picture this. Imagine a grand royal palace. Queen Ratnamanjari had a will written that described her massive fortune of precious stones, called Ratnas. She invited her son, Koisnam, and their 99 relatives to hear the will. Now, she really wanted to leave all her treasure to her son, but to stop the relatives from complaining, she set up a puzzle. She basically said, if all 100 of you answer it at the same time, you share the treasure. But if you're the first one to solve it alone, you keep everything. So the royal minister takes Koisnam and his 99 relatives to a secret room. And in this room, exactly 100 lockers lined up in a single row. Now, let's carefully look at the rules the minister gave them. Each person gets a number from 1 to 100. Person 1 walks down the line and opens every single locker. Person 2 goes to every second locker and toggles it. Now, what does toggle mean? It simply means changing the state. If the locker door is open, you close it. If it's closed, you open it. Make sense? Then person 3 goes and toggles every third locker. So the third, the sixth, the ninth, and so on. Person 4 toggles every fourth locker. And this keeps going until all 100 people take their turn. And here is the central puzzle. After all 100 people finish, which lockers will remain open at the very end? The open lockers will reveal the code to the safe. But here's the amazing part. Before the process even began, Koisnam realized he already knew the answer. How on earth did he figure it out so fast without opening a single door? Section 2, Discovering Perfect Squares. This is where we find our key. To solve the locker mystery, we need to understand perfect squares. The squares of natural numbers are called perfect squares. Now, natural numbers are just your simple counting numbers, 1, 2, 3, 4, and so on. When you multiply a number by itself, you get its square. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. These numbers, 1, 4, 9, 16, 25, these are our perfect squares. This brilliantly illustrates how squares work in real space. Imagine a giant grid right in front of you. If you have a square shape with a side length of 2 units, its total area is 2 multiplied by 2, which equals 4 square units. Literally, imagine 4 small boxes making up a bigger square box. If the side is 3, the area is 3 multiplied by 3, giving 9 square units. If the side is 10, well, 10 times 10 gives 100 square units. Okay, so how does this solve the Queen's puzzle? Well, if you track how many times a locker is toggled, it all depends on its factors. Most numbers have an even number of factors. That means their locker gets opened and closed equally, so they end up closed at the end. But perfect squares, numbers like 1, 4, 9, 16, and 25, they actually have an odd number of factors. Because of this, their doors end up open. Koisnam knew his perfect squares, so he instantly knew the winning locker numbers were 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Boom. Mystery solved. Section 3, Proving with Algebra. Now, what's really interesting about this next part is how we use letters as our best detective tools. Let's look at a direct question from your textbook. Will the expression 4m plus 2q always evaluate to an even number for any integer values of m and q? Now, imagine m and q can be literally any whole numbers. They could be 5 or 10 or even a negative number. How can we be absolutely sure the answer is always even? I mean, we don't have time to test every single number in the universe, right? Well, here is method 1, using step-by-step logic. First, let's look at the term 4m. If you multiply any number by 4, the result is always an even number. Next, we look at 2q. If you multiply any number by 2, the result is also always an even number. Finally, think about this. What happens when you add 2 even numbers together? Their sum is always even. It's a simple, beautiful rule. Therefore, 4m plus 2q absolutely must be even. And here is method 2, which uses algebraic factoring. We can actually rewrite 4m plus 2q as 2 bracket 2m plus q bracket close. What we did right here is pull out the number 2 as a common factor. Because the whole expression is now 2 multiplied by something else entirely, it means 2 is a factor of the final total. And any number that has 2 as a factor is, by definition, an even number. This is exactly how we prove things in mathematics without ever having to guess. Section 4. Exploring math patterns. Here are 2 very famous identities straight from your NCERT book. On the left, we have a plus b whole squared equals a squared plus 2ab plus b squared. Remember that small number 2 next to the letters? That simply means squared, or multiplied by itself. Now, on the right, we have a very similar pattern. A minus b whole squared equals a squared minus 2ab plus b squared. These patterns, they act like magical shortcuts for solving much bigger arithmetic problems. Let's look at a specific textbook example to prove this pattern actually works. Take 2 numbers, 5 and 6. The textbook asks us to notice this pattern. 2 times the sum of 5 squared and 6 squared. If you apply the identities we just saw, this is exactly equal to 6 plus 5 whole squared added to 6 minus 5 whole squared. If you write out the math on both sides slowly, they balance perfectly. Algebra just gave us a foolproof formula to combine and separate numbers. Here is another quick, really useful pattern. The sum of 8a and 8b is always a multiple of 8. Why? Well, because the 2 numbers have 8 as a common factor. Multiples of 8 are obtained by repeatedly adding 8. So if you take one multiple of 8 and add another multiple of 8 to it, the total sum will also exactly divide by 8. It's literally just like stacking blocks of 8 together. Section 5. You can do this. Let me share a great quote with you from the book. Wondering and posing questions is as much a part of mathematics as problem solving. You know, when you look at an equation and ask yourself, what if, or will it always happen? You're thinking exactly like a true mathematician. Asking those questions is the very first step to finding the answers. I really want to assure you that math isn't magic. It's simply a series of logical steps, just like the locker puzzle of Queen Ratnam we solved earlier. Mastery doesn't come from being born a genius. It comes from steady, daily practice. Just take it one step at a time, use your textbook, and write your steps down clearly. You've totally got this. So you have all the tools now. Perfect squares, factoring, and patterns. If you can solve Queen Ratnamanjari's 100 lockers, what other grand mysteries in your textbook are waiting to be unlocked? Open your book and begin your next investigation today. Thank you so much for learning with this explainer.